Okay, this is lesson 22, MAT 175, and we're working on the second half of this lecture. And now we're looking at an example of radioactive decay. And this is polonium-210, has a half-life of 140 days. Now on the other video that I gave you, I showed how the half-life works. Basically, when you're given the half-life, you have to use the equation of natural log 1/2 over the half-life. And the half-life can be in days, can be in minutes, it could even be in seconds, minutes, months, years. So you have to look at the units. In this case, it's days. So we want to pay attention to that because that could play a factor later on in the problem. Okay, so we use the half-life to calculate our decay rate. We're not going to be given the decay rate. We have to go ahead and figure that out. So in this case, we're given the half-life of 140 days. Suppose that a sample of this substance has a mass of 300 milligrams. Okay, so this would be our beginning mass here, our beginning amount. So like with the population equation where we had A sub O was our starting population. Now this would be our starting mass. So the first thing that we have to do is to find the decay rate. We got to find K. So we're going to go ahead. So our equation is for to get the decay rate, knowing the half-life, is natural log 1/2. Or I'm just using 0.5 over the half-life. So our half-life is 140 days, so this would be natural log 0.5 over 140. Okay, so now every 140 days, our mass will literally cut in half. Okay, half of it will no longer be polonium-210, it'll be some other substance. There'll be something there, it just won't be polonium-210 anymore. It'll be a lesser radioactive substance. So we go to our calculator, and we're going to go ahead and put in natural log 0.5 and divide that by 140. Okay, and we hit enter, and we get a negative, and there's that decay rate. Notice this is our mass is declining, so our rate is also, our mass is going to be declining at a negative 0.00495, and it goes on. So we're going to store that into X and hit enter so that we can use that in our calculation. Okay, so here's our rate, and now we want to know how much is left after 1 year. Okay, so now in this case, our T. What are we going to use for T, since we're looking for how much is left after 1 year? 365, very good. Because why? Right, because our half-life was in days, so our decay rate is in days. So we have to look at how much is left in days. So we set up our equation. There's our initial mass, 300. There's our decay rate, 0.00. That should be a 0 there. Negative 0.00495. But since we stored the negative into X, you don't have to put the negative in your equation because it's there. It's an X. And T is 365. All right. So this is A of 365. Okay. You're not going to use this A 365. You're not going to use this on the left side of the equation. That's like f of x, where you substitute, like if you want to know what f of x is at when x is equal to 2, you substitute 2 into the x. Well, that's what this is. Only here we're substituting 365 into t, since t is the independent variable, not x. All right, and so this will be 300 times e, and then this is the negative 0.00495 times 365 as an exponent. So on the calculator, the way we enter this is we're going to put in here 300 E, and then we're going to put in 365X. Since the negative 0.00495 and it goes on is in X, then we don't have to enter the negative. It's in X. And notice on this TI-84 plus Silver Edition, I have to use the parentheses here. All right, and so we hit enter. And so now, after 365 days, we went from a mass of 300 milligrams down to 49.237 milligrams. Okay? And so that's our resultant mass. Any questions with that? Okay. Let's see what else we need to do. How long will it take for the mass to decay to 200 milligrams? So off to the side here, where does our question mark go now? We still have 300, and we still have a decay rate of negative 0.00495. So the initial mass and the decay rate are the same. Okay. So what are we looking for now? T. We're looking for T. And T is going to be in what units? Days, right. So where does the 200 go? The A of T, very good. All right, so there's our setup off to the side. Our question mark goes with the T. So this would be 200 equals to 300E, negative 0.00495 T. Okay, so now we divide 300 into 200, cancel the zeros out. And then we apply natural log to both sides. Okay, questions with this so far? Okay, so if you've been calculating along with me, go ahead and try to figure out how long will it take for our a mass of 300 to decay to 200. And while you're doing that, I'll work this out here. All right, so this will be okay, anybody get a number? All right, you should have taken natural log 2 over 3, right? Now you could have gone ahead and hit enter, which normally that's what we do. And then what are we going to do after that? Divide by, in this case, x, because x has the negative 0.00495. So we're going to divide by x. Okay, and what happens here is we get 81.89 milligrams. So what happens here is the two negatives cancel. Okay? If you end up with a negative value other than K, then chances are you're not going to have a negative mass, right? So chances are what happened? Something got messed up, right? Something's wrong. Okay? Because we don't work with negative mass. Okay, and that'll tell you what to round that off to.